Okay guys, I just want to go over vector value functions with you today. Uh, some of this might be new, like what is a vector? In general, a vector just gives you a direction and a distance. The distance they kind of like to call magnitude. Higher level math, they'll call it like kind of like a force. So you'll see it in this notation where you have, instead of parentheses, you have these brackets, or they look like a greater than or less than symbol. But basically, just to go over what a vector is, like if I have the vector 2, -3, it's giving me an x and a y direction. So this is telling us, the direction that we go in. So you're always starting at the origin. And what it basically does is it's going to move 2 over in the x direction and 3 down, or 3 in the y, -3 in the y direction, and it just shoots a point onto the graph, basically saying that pink line is not part of your function. That when we start getting into this, the only thing that we have here is this is 2, -3. That is our vector that's telling us direction and distance. The distance, the way you would figure out distance is, well, if you guys notice, it makes a right triangle. So really you could just take Pythagorean theorem and you could find the distance of this, which we could do that now, which is called magnitude. You'll see notations like this, with you have like a double absolute value symbol where you're getting 2 squared plus -3 squared. So in this case, 4 plus 9, so square root of 13 would be the distance. So a brief little overview. We'll get back into this as we go on and on, but really for the AP test, this notation is what you want to keep in mind, because when they start asking for derivatives and all of that, eventually we're going to do position and trying to get distance traveled, all those sorts of things with these vector value functions. But if you notice, they're just made up of, it looks like our parametric, where you have x of t, y of t. So just to make up one, if you see something like this, say it looks like t squared and t, right, for example. So what does this look like? So let's just say, right, we know if it's x comma y, so x has to be t squared, y has to be equal to t. So we could do is substitute in y for t, so you have x equals y squared. Okay, and we all know what that looks like, where you would have your, if you want to write it this way, okay, you would have something that looks like that. In general, if you did a table of values for t, you would get your x and y coordinates. So for example, like if we pick 1, well, let's start with 0. If we pick 0, we would wind up getting 0, 0. If we pick 1, we get 1, 1. 2, we get 4, 2, and so on. So really in this situation, we're only looking at the top portion. Okay, so like here you would have time equals 0 gives you that vector. Okay, so again, let's make them into vectors. Okay, and then the next one would be 1, 1, right? You would have a vector, say that's 1, 1. And then you would have 4, 2. Okay, what is going on is, like I was saying before, each vector is being plotted onto the curve itself. So that's a brief description of what a vector value function would be. And now we're going to start taking the derivatives of those functions. So let's do an example here. What if we have a vector value function e to the negative t and then cosine t. So if you have this vector value function and I want to find the derivative, pretty straightforward. You're just taking the derivative with respect to t of each component, your x component and your y component. So here we would have negative e to the negative t, and you would also get negative sine t. And you're done, and that's your derivative. If you want to continue and go for your second derivative, you do the same thing, just with the first derivative. So and here you would get an e to the negative t, comma, negative cosine t. And there would be your first derivative, and there would be your second derivative. So nothing that's really that complicated. I believe that probably this section right here might have been a little confusing, but just think that, you know, they're just giving you directions of how to place the points onto the curve as it moves along. And then you could get this, you know, if we're looking for speed or acceleration, we could use, you know, first and second derivative as we go along. So that's just a little brief intro of vectored value functions. So hopefully it works for you guys, and you guys could try with, I'm going to put Khan Academy, and I know there's already an assignment on the College Board site. So hope this helps. Email me if you have any